Hello. One of the most common types of artifact on many archaeological sites is pottery, and it's important for archaeologists to know how to illustrate pottery. You might ask, why do we need to make drawings of pottery when we can just photograph them or even do 3D scans? In fact, there are very good reasons for doing pottery illustration. And in today's video, I want to talk about those reasons as well as show you in practical terms how you go about illustrating pottery, including small sherds as well as whole vessels like that one back there. The whole vessels are a lot more difficult to draw than small sherds are. So I'll show you techniques for doing both of those things, as well as walk you through the process from the original, some cases pencil drawing or scan of a pencil drawing on a computer, to a final so-called inked drawing. It's usually these days a computer illustration that would be suitable for publication. It's a fair question. Why would you make a drawing when you could take a photograph or even do a 3D scan? In fact, there are several reasons to draw pottery. First, it forces you to examine the sherd very carefully and select only those attributes to illustrate that are important for the interpretation of the sherd. You don't want the viewer to be distracted by things like post-depositional damage or carbonate incrustations. You also want to use all the relevant information you can gather from the sherd to reconstruct as much of the vessel as possible. In addition, you want to represent the pottery in a very standardized way. This involves using a graphical information language. Just as with a digital information language, this involves standardized symbols to represent different kinds of attributes. Normally, we find fragments of pottery, potsherds, rather than whole vessels, although sometimes we find whole vessels and you need to know how to draw those. But first of all, think about some of the things you have to observe on the pottery in order to do a drawing. A very important one is the stance line. So the stance is a plane we think of as being a horizontal plane that would touch the complete surface of the top of the rim or the bottom of a base. And a very useful tool for drawing a potsherd at stance is called a stance block, which is a piece of wood that you can put against the pottery that would define what the stance line should be for that pottery. I'll talk more about that later. But keep in mind that normally we draw rims so that the rim is horizontal at stance. We also want to pay attention to the longest vertical section that we can get through the sherd. So that's going to be, in this case, from here down to here. So it's going to be from the rim down to the lowest point that we can find on the vessel wall. If it happens to be a rim sherd, if it's a base sherd, it's the opposite. It would be from the base up to the highest point that we can find, because you want to be able to preserve as much of the profile of the pot as possible. So it's very important to find that long section. Even when you're doing digital illustration, you usually start out with a pencil drawing. So for example, for relatively small sherds, you might do a pencil drawing on a file card. This is handy because then you can file them away in file boxes and pull them out when you want to finish them off on a computer or by inking if you're using the old-fashioned methods. And I don't know how well you can see this, but one of the important things on this card would be the stance line. So it's very important to know what the stance of the sherd is. So you would draw a straight line on there, and in fact you would align, when you're doing the drawing, you would often align the stance block on there to make sure you're holding the sherd at the correct angle when you're doing the drawing. And then you draw a section of the sherd below the stance line if it's a rim, or above the stance line if it's a base. And then you also can do inside and outside views of the vessel walls if they have features that are worth recording. And then you can scribble comments on this card that describe different aspects that have to be on the final drawing, such as color, whether or not there's a slip, or burnish, or painting. In this case, there's a little knob near the rim, so you can make a comment on that, and on the section part of it, it shows exactly where that knob goes and how far it extends above the surface of the vessel wall. So that's all very important. Of course, not all projects use file cards for their pencil drawings. Some of the alternatives include graph paper or vellum, a type of draftsman's tracing paper. On all of these media, it's important to record all of the details that the draftsman needs to know in order to finish the drawing, as well as information about the archaeological context. Now, one thing I should mention is that when you're drawing artifacts, it's very important to be sitting where there's good light, preferably near a window. Again, with any kind of lab activity that involves you using your eyes, you want to avoid eye strain as much as possible. And a lot of this is pretty close-up work. And so then when you're drawing, you want to be able to look out the window once in a while to refocus your eyes on something far away so you don't get as much eye strain. And of course, the other obvious reason to be near a window is it gives you good light to see what you're drawing and make sure you do your drawing properly. And as with any illustration in archaeology, you tend to want to have the light coming from the upper left. And so you might even want to angle the table a bit to make sure that light's coming from that direction. So if you're doing any shading as part of your drawing, you make sure it's easier for you to put the shading where it belongs in order to make an effective drawing. What I'm first going to show you is how you would draw pottery that's been cut. What I mean by that is that someone has, quite often in archaeology we want to do petrography, petrography on the sherds to find out what the fabric is. In order to do that, we have to take the pot sherd and put it on a saw and cut a piece off of it. It's on a radial section normally. Sometimes you do other sections as well, but the radial section is pretty standard. So here we have a rim sherd, for example, that's been cut into a radial section. And when you cut it on the saw, you want to make sure you cut it on a vertical line relative to the stance, so it's perpendicular to the stance, and also that it really is a radial line through the sherd so that it's also perpendicular to the walls of the vessel at the point where it cuts through. Once you get that done, of course it's easy to see what the cross-sectional shape of the sherd is because you've already got a physical section through it. And if you were to put it down on a piece of paper, it's very easy to trace the sherd to get the shape reproduced pretty carefully and pretty accurately. Although one thing that can happen, will happen actually, when you trace it with a pencil, you're going to actually get a drawing that's a little bit too large by the width of the pencil lead. So we use pretty thin pencil leads for this, but even so, you can get a slightly bigger drawing than the actual sherd, which means you have to keep that in mind when you're actually doing the final drawing. You want to keep inside those lines. Now, when you are drawing ones that are cut like this, so these are the easiest ones. It only applies to usually the ones where we anticipate having to do petrography on them. But the first thing you want to do is have a stance line. So whatever card or piece of paper or whatever it is you want to use for your rough drawing, you first draw a stance line against the stance block, and then while the stance block is still there, you can now put the pot sherd up against the stance block and move it around until you get it at stance. Okay, so that's now at stance, and then you hold it in place, and then I can trace it with my pencil, keeping as close to the sherd as possible, and then I stop where the break occurs. And I can also do that on the outside, like so. So that when I take the sherd away, there I have a rough tracing of the thing. It's a little bit bumpy because this is kind of a rough sherd. Now, another tool you can use, this is something that was developed by the late Jack Holliday. He published an article on it in Antiquity. This is a setup designed so that your pen is held at a 45-degree angle so the tip of the pen goes as closely to the sherd as possible when you trace the sherd with this up against it. This tends to work better for bigger sherds than this, so I didn't use it this time. But this is a handy device to make if you are going to be drawing a lot of pottery and some of the sherds are bigger than that. So one's on the order of this size, and if you anticipate the sherds are going to be cut. Not cutting the sherds, it's not as useful. So we now have pencil drawing. Doesn't look too pretty, but it does record the exterior and interior profile of the sherd as well as the stance line. Let's see. Yeah, that looks good. And just in case one forgets, because in this case it might not be very obvious which is exterior and which is the interior. We can label it to make sure that we know that this part is this surface is the exterior surface. Here's another example of tracing a cut sherd. To start, we have to make the stance line. Then we stance the sherd against the stance block, making sure that it's still on the line. The next step is to trace the outline of the sherd. I recommend making a couple of caliper measurements in order to ensure that the drawing is accurate. The thicknesses look pretty good. Next, we need to know the rim diameter on the interior or exterior, whichever is most convenient. So we determine that with a diameter chart and record it directly on the drawing. Finally, we make sure that the artifact number is on the drawing. This preserves the information about the archaeological context. In many cases, we have to draw pottery that has not been sawn, and that's a little bit more difficult. So a sherd like this, for example, that has not been sawn along the vertical, longest vertical radial section that we can make, for ones like that, you have to use the profile gauge. The profile gauge like this will work pretty well on sherds that are pretty hard and whatnot. On a soft sherd, I wouldn't want to do this because it gets it's very high risk of damaging the sherd. But to get the exterior profile in this case, we need to kind of gently press profile gauge up against the sherd at an angle that is as close as possible to perpendicular to the stance line. Again, we begin by tracing a stance line along the stance block. Then stance the sherd's rim against the block in such a way that at least part of the sherd touches the paper. And make a couple of pencil marks to show how the sherd is oriented against the stance block. The next step is to get the profile of one of the sherd's surfaces. Push the profile gauge gently but firmly against one surface of the sherd, taking care to make sure that it's perpendicular to the sherd's rim. Line up the indented part of the profile gauge with the small dots you made earlier when you stanced the sherd against the stance block. You'll want to do this close to the edge of the drawing board so that the profile gauge lies flat. And carefully trace the edge of the profile gauge. Then use the profile gauge on the other surface of the sherd, again being careful to place the profile gauge perpendicular to the stance line. Take caliper measurements at both ends of the sherd. And transfer those measurements onto the drawing by placing small dots that show where the second profile should line up. Turn the drawing around and shift it towards the edge of the drawing board so that you can place the profile gauge where it belongs next to those little dots. Then trace the profile gauge again. Compare against the broken edge of the sherd to make sure the drawing looks okay, and that you haven't missed any important details. Making small adjustments to the drawing is needed. Then take 2 or 3 caliper measurements to make sure that the thickness of the sherd is properly represented on the drawing. I recommend making these measurements at both the upper and lower ends of the sherd, as well as at important landmarks like the thickest portion, or where there's a bend in the profile. Again, make small adjustments if the thickness isn't represented correctly. Retrace the profiles so that they're smoother and that you make sure that they show up on a scan. For rim sherds, trace either the interior or exterior rim in order to preserve evidence of the diameter of the sherd. In this case, we label that arc as the interior diameter. Although we could measure that diameter later on, here I'll measure it right away using the diameter chart that's attached to the drawing board. I then record that directly on the drawing, along with the estimated vessel equivalents, or EVE, or percent of circumference, in this case 25%. That's a useful measure of preservation that I discuss in my video on quantification. Finally, check to see if there are any surface details that should be on the drawing, such as the sloppy red slip on this sherd. Notations on the drawing will indicate the extent of that red slip, so that can be indicated on the final drawing. I'll also make a notation to indicate that the slip is worn off in the neck region of the sherd. Very importantly, make sure that the artifact number is on the drawing in order to preserve evidence of its context. Remember when we used the cut sherd, the pencil line was adding thickness to the sherd. In this case, because we're actually tracing on the inside of the profile, it's actually not adding to the thickness of the sherd. It's actually a line, it's on a line that's actually pretty close to where the sherd boundary should be. If anything, it's the exterior part of the line that's the true line. However, there's one other thing we want to check to make sure that we have these things done correctly and that we stanced it correctly. If you stance the sherd on just on your table, and you take a right angle triangle, preferably one that has centimeter scale on it, and then you measure from the stance line. Remember, the table now is the stance, the plane of the stance. You measure at a right angle up to the farthest distance that the sherd is preserved, and we want to make sure whatever that distance is. Again, this one's not graduated, unfortunately, so I would have to use a regular ruler to do that. Ideally, this should actually be on a right angle triangle. Pretend this is a right angle triangle for the moment. Measure that distance, and I can see it is, when this thing is stanced properly, it is about 7.3 centimeters. So I can also draw that on the drawing. That's 73 millimeters, in other words. 73 millimeters from here to here. Right, so at right angles to the stance, it should be 73 millimeters down to the bottom of the sherd. You could actually use either the vertical height or the horizontal distance between the rim and the shoulder of the vessel in order to check to make sure that the sherd was stanced correctly for the drawing. So that's important information to record as well to make sure that everything is accurate. Now that's particularly important when you have quite large sherds like this one, because again, if you want to make sure, we can use the profile gauge again to measure this fairly complex profile of this sherd. But to make sure that we get it right, you want to make sure you measure up to the highest point here, and let's say that's 95 millimeters or something like that. Then we know that on our drawing that distance has to be 95 millimeters. So it's a good way to check your drawing to make sure you've got the stance correct. Although archaeologists normally deal with sherds rather than whole vessels, The convention for illustrating pottery is to reconstruct as much of the vessel as the evidence will permit, and to show it in a cutaway view so that one half of the drawing shows the interior and cross-section of the vessel and the other half shows the exterior of the vessel. To do it with the actual drawing, the reconstructed drawing of the pot that we've already done a rough drawing of, the old-fashioned way would be to use tracing paper. Nowadays, we would instead take our rough drawing, scan it on a flatbed scanner, and do the rest of the drawing on the computer. But just in case you ever have to do it by hand, I'm going to show you how that's done. So we take a piece of tracing paper, something that's reasonably translucent, so that when you lay it down on your rough drawing, you can actually see your tracings through it and the stance line. If necessary, use a light box, just a box that has a sheet of glass on top and a light inside, so when you put the paper on top, it's very easy to see through it. But this is translucent enough that I don't really need a light box. And what we do is we check the original drawing where it should say what the diameter was, and for this particular sherd here that we started out with, this is one of the cut ones, the interior diameter was 15 centimeters. So what we want to do is take a ruler and draw a line segment that is 15 centimeters long. And we also want to bisect that line so that would be at 7.5 centimeters. So we'll draw a little tick where that is. And here's where our right angle triangle comes in. We now take the right angle triangle and we make a perpendicular line at that tick mark so that we end up with what looks like a T. And that vertical line segment represents the center line of the pot. So we're going to have a profile of the pot on one side and the exterior view of the pot on the other side. And there's no widely accepted convention as to which side should be which. In North America, there's a tendency for the profile, the cross-section to be on the right, the exterior on the left. In Europe, it tends to be more the other way around, but there's no hard and fast rule. So now what we can do is line this line up with our stance line such that the interior surface of our profile that's drawn here touches on there. And just because of the way this one's done, I'm going to draw the section on the left, but it doesn't really matter. Or actually, maybe I won't. Maybe I'll do it on the right. The thing is, if we do it on the right, I'm going to have to flip this paper now. I'm going to have to trace it backwards. And then you'll see why now, because that was the interior diameter. So you make it, so I'm going to make it so that this point, right at the end of my line segment, matches up with where it just touches the stance point on the interior of the sherd. So I've done that here. Okay, now I can trace. So I now trace that. I also want to retrace it on this side when I flip it the other way around, so it's properly visible. Okay, so I've now got the section drawn on that side. Now I want the exterior profile to be on this side, so I have to, in this case, I don't have to flip it around. The exterior is on the right side. Again, I want the stance line to match up so that this touches the interior, where the interior of the rim is, and the stance line is lined up. Make sure the stance line is correct. Okay, but this time I'm not going to trace the interior part of the profile, only the exterior. So we end up with a drawing that looks like this. I'm going to move it a little bit closer so you can see what I've done there. So we have the cross section on one side and the exterior profile on the other side, and then the vertical line down the center. Now to finish that off, because we have some kind of molding on the rim here, we need to also draw some horizontal lines to represent that. So again, we want to use our right angle triangle for that. So So we can see that there should be a bit of an overhang here. So we line the triangle up on the center line. And we draw like that. Something else that needs to be represented there. I think that's probably it for the exterior. Anything on the interior? Not so much. Sometimes there would be a groove or something on the inside, in which case we might want to put some lines across here, but in this case there's no need for that. So you can see that the drawing is going to look kind of like that. So we have a line, horizontal line representing where there's that change in angle on the exterior part of the pot. But you might actually want, since it's got a bit of a groove there too, I suppose we could actually add another line to represent that. Anywhere where there's a sharp change in angle on a sherd, you want to show a horizontal line to represent that. A really common mistake is to misrepresent complex rims that have overlapping sections or folds. You need to keep in mind that this half of the drawing is supposed to show the vessel as it would appear from the exterior and at a horizontal angle of view. Consequently, the underpart of this overhang would not be visible. You need to correct that part of the drawing with a horizontal line that hides part of that overhang from view. Then add other horizontal lines as needed to indicate the complex molding on the rim. Now, when this is inked, either if we're inking it by hand, we would now then use this paper drawing. We put a piece of probably mylar, which is kind of a plastic paper. It's translucent. And because it's made of plastic, it's much more stable. It's made of mylar, actually. It's much more stable than paper is. Paper expands and contracts with humidity, so it's not very accurate for long-term storage of a drawing, whereas the mylar doesn't do that very much at all. So it doesn't absorb moisture from the air. So we would then take the sheet of mylar and put it on top of this drawing, trace it yet again, but this time trace it in ink. And when we did that, most likely we would color in the cross-section in black. And the stance line, we would stop it just short of the section because we don't want the ink to bleed into the section, making it hard to see what the shape of the rim is here, what the lip is. Here it's a rounded lip, but if you made the stance line go right up against it, it might make the lip look kind of pointed, which is not what you want to do in this case. So far I've talked to you about how to draw sherds, but sometimes you have to draw whole vessels like this one here. On my project we don't find vessels like that very often, but occasionally it does happen. Some projects more than others. And generally speaking, you want to draw one of these without sawing it in half. So it's important to know how to do that. Particularly tricky when it's quite a large vessel. This one's fairly large. I've drawn some that are twice as high as this, but you use the same methods I'm about to show you. In order to do that, the main thing to start with is you want a profile of it, and your profile is going to be, because this is a two-handled jar, you want a profile in this plane that cuts through both of the handles. If there's more than two handles, it's a slightly different issue, but for a two-handled jar like this, that's the sensible way to do it. So in order to draw it, we want to be able to tilt this thing on its side so those two handles are parallel to the ground, and the long axis of the vessel is also parallel to the table. So how do we do that? Well, to start with, we need to have something to park this in. Ideally what you want is some kind of a donut-shaped pillow or something like that to support this thing that's a little bit more flexible, but since I don't happen to have one here, I don't often have to draw full vessels, so I'm not really set up for that. So you put in this case I'm going to put a bowl on the paper I'm going to draw on. By the way, this is not proper vellum that I would normally be drawing on, but I seem to be out of it. So I'm just using some brown paper here. So we can now plop this vessel on the paper. This one you may have noticed there's actually a hole inside of this because it's been sampled for residue analysis. But ordinarily we would want to cut this thing in half. So we park it on the table like this, so it's sitting in a bowl. And as long as you use a pillow or a bowl that's smaller than the pot is, so it's not going to show up when you kind of project the profile of the pot down onto the paper, it should be fine. A bowl that's too big is not going to do the job properly. As I mentioned, a donut-shaped pillow is actually the ideal thing. Now we need to figure out whether or not this is actually horizontal to the paper. And the way we do that is go back to our squares, our right-angle triangles, that is. And also we need a ruler. Let me grab a ruler from here. Actually, that's not a very good ruler to use. Let's use this one is better. What we want to do is we need to make sure that the measurement to the center of this base is the same as the measurement to the center of the opening at the other end. And also, ideally, if it's at stance, the base should be square onto the right angle triangle. That's probably not too bad there, but we would want to measure here, it's 24.5 to there, which means halfway point would be just short of 7 centimeters, so that's about 16 3/4 centimeters to the center of the base, and we want to make sure it's the same to the center of the orifice. And it is not, so that means this needs to tilt up a bit. Okay, so now the center of the orifice there is, let's see here, 15.5, so it's 15.5 centimeters to the center of the orifice on that side. And let's see what it is on this side now. Actually, no, that's pretty good. So we now have it so that the axis this way is pretty well parallel to the paper. We also want to make sure that the two handles are parallel to the paper, and that means we want them so that if you take any measurement on the handle, you just want to make sure that they're the same height. Okay, now that should be pretty good. It's 18.25, and that's 18.25, so that's about right. So we now have the pot oriented above the paper in such a way that a cross-section through the middle of the pot and the two handles would be approximately parallel to the surface of this paper. Now, ideally, if you're doing this a lot, you would get a right-angle triangle that has another small right-angle triangle glued onto it at right angles, so that when you set it up, it's always going to be perfectly straight and vertical. See, now, since I don't have that, I have to kind of eyeball the vertical, and that's pretty good. So if I make a dot on the paper here, that dot should be basically in line with a straight drop down from there. And I have to work my way around the pot, making little dots as I go, making them fairly close together. Again, you always have to make sure the right angle triangle is nice and vertical. Right there. And then here we've got the base. Should make a pretty straight line across here. Anyway, you do this all the way around the pot. So this will actually work even in the case of pots that aren't perfectly symmetrical, because you're going to go all the way around. And you also, again, want to make note of the fact when you're at places like where the handle attaches. Just a little arrow on here, say bottom handle. And then we've got the rim stance line. Anyway, so you can do that all the way around on both sides. I'm not going to do the other side right now because it'll take up a lot of your time. And then for the stance line, just run through those dots I just made. I'm going to go up to the rim here. And then it's kind of like fill in the dots. You might want to kind of eyeball it. Remember, you got to, again, think about parallaxes. If you're not looking straight down, it's not going to match up properly, so you have to keep making sure you're moving your eye along as you trace between the dots. And then I could use straight edge again to make the base. Oops, didn't do that very well. That. Now, where you run into problems is where the inside of the handle is, because obviously I can't put the right angle triangle up to that. So then I have to switch to calipers. And where did I put my calipers? There they are. So I have to take caliper measurements to find out how thick the handle is at each point. And fortunately, I marked where the beginning and end of the handle is, so I know where these go. So I'll put one that's just about a centimeter up from the beginning of the handle. That is at 14.9 millimeters. 14.9 would be about there. And halfway along the handle is 14.3. It's the top of the handle. It is 15.3. And I can join those points together also. And then the tricky part here is figuring out how the vessel extends, or the vessel wall extends inside the handle. And that, again, you have to really do with measurements. So in this case, we'd want to measure, this isn't really the right ruler to do it with, but you'd want to measure from the exterior of the handle where we have the most certain line into where the vessel wall is. And that looks like it should be about 3.5 centimeters. Centimeters to here. And we also know it's going to continue this curve here. So it's going to go something like this. And then again, we can kind of eyeball it, but you have to be careful about the parallax. It's going to go something like that. This goes like that. Okay, so that we do that on both sides. We get the exterior profile and the handles in place. Oops, I also forgot. I also have to do it here. Here you can't really measure it anyway, but it's, you know, it's going to be something like that. Because it's the way the handle is smudged on there anyway. If you want to get that really accurate, you have to tilt the pot the other way to get this profile, the profile of the neck someplace where there is no handle. That's actually how you do it to do a proper job of it. Now, the interior, obviously we can't do this on the interior, and there's really not a whole lot we can do. Right near the opening, you might be able to use the profile gauge to get some of it, and there is actually kind of a groove in here, which is kind of important. So instead, but failing that, you have to make do with some caliper measurements as far down as you can get them. So the thickness here is 11 millimeters. And I can say that that goes down, where that groove is about 12.5 millimeters down. So it goes, and I can see it's a little bit of a pointed rim. It needs to be rounded, but a little bit pointed. And then there's a groove, and then it gets wider. So I'm measuring from the outer part of the rim to where the main surface of the neck goes. Is that, oops, that distance, so that's about 15.8 millimeters. Measured from here. There. And then if I measure it as far down as the calipers will go. Okay, so we now have the cross section as best we can reconstruct it. It's not perfect, and you can do a little bit more careful job than I just did, but you only get it down so far. And as I say, if you can manage to sneak a profile gauge in here, you might be able to get it a little bit farther down. But then you kind of run out of steam. So unless you have some very large calipers that you can get down there to do thickness measurements at various points along the vessel walls, there's not much you can do about the interior, other than you can just make kind of a dash line here, estimating where the vessel wall would be. This actually has a concave base, and to get that concavity and the thickness of the base, we can actually do a ruler measurement. If we take a ruler that actually starts at 0 at the right place, this one doesn't, and we put the ruler all the way down to the center of the base, and then use our triangles here to make sure we're at stance. And then for the concavity here, we can use the right angle triangle here, and we take a ruler measurements this way. Again, using them, you have to make sure you use a ruler that starts at 0, which these ones don't. They're a little bit offset, so it's not going to be an accurate number, but we'll ignore that for the time being. And let's say that that is one centimeter or something, and we know that at the center line, the concavity here is 1 centimeter.
We could also use a profile gauge here to represent the concavity more accurately.
And then we also would have the thickness measurement here. But then everything else, we just have to guesstimate it by dashed lines on the interior, something like. Anyway, that gives you an idea of how you would draw a very large vessel like this. So just to give you an idea of what one of those drawings would look like at the end of the process when you're trying to draw a large, complete vessel, I have this pot here, which is, you can see there's a repair on it there. This is a water jug, about 100 years old, from Palestine, called a Gazaware pot. And again, like that one I was drawing a minute ago, it has 2 handles on it, so we'd want to have the drawing in this plane, so the handles show up like that. And so there's the pot. I used the exact same method that I just showed you to draw that pot. And here is the drawing that resulted. And as I was saying, you'll notice because I couldn't take measurement, my calipers weren't big enough to reach very far into the vessel. I had no basis for deciding what the thickness of the walls were on the way down. So most of the interior profile is missing. I did as much as I could. The exterior is reasonably accurate, and then of course the handles are reasonably accurate. And I also did a cross section through the handles because these are what are called strap handles. So they're wide. So when you have handles, you usually want to have a cross section through the handles as well, in a different plane that shows whether they're wide or narrow or round or flat or whatever. So that's how it ends up. This again, I knew the thickness at the bottom of the vessel because I stuck a ruler down the middle with where it intersected the triangle at the top. I was able to figure out what the depth of the vessel was. So I can reconstruct a little bit at the bottom, a little bit near the top, but most of the interior line is a mystery.
As I mentioned earlier, today you wouldn't normally finish a pottery drawing using pen and ink. Instead, you'd scan the pencil drawing in order to turn it from this into this. Key requirements for this are a flatbed scanner and a computer running some form of illustration software. First, you scan the drawing and save the file. Then open the file with the illustration software. Here I'm using Adobe Illustrator, but other illustration software works much the same way. Check to make sure that the stance line is horizontal and correct it by rotating if it's not. If there's not already a line segment marking the center axis of the pot, you should add one at half of a diameter from the rim profile. A very important feature of the software is the ability to make layers. You'll want to keep the original drawing in the bottom layer and lock it so you don't accidentally move the drawing around. Add new layers for different aspects of the drawing. Here I'll add a layer for my tracing of the drawing and give the layer a name. Next, I select the Pen tool, go to the Properties panel, and select the options for no fill and a pen size of 1 point. I'll enlarge the image to make it easier to trace the profile accurately. Then click the pen repeatedly along the profile in order to trace its shape. You'll want to have a convention to show where the break occurs. Here I'll just use an angular indentation. Because my tracing currently consists of a series of small line segments, I'll want to smooth that out. So I select the shape that traces the sherd cross-section, go to the Object menu, and select Path. From the Path submenu, I select Simplify, and then slide the circle downward slightly on the bar. It takes some practice or trial and error to figure out how much you need to slide it, as you don't want to smooth it so much that it no longer accurately traces the profile. Then I select the shape again, go to the Edit menu and select Copy, and then Paste. This gives me a duplicate of the cross-section that I'll use for the other side of the vessel. I'll now zoom out the view to accommodate the vessel's diameter. Then select the duplicate cross-section, and from the Object menu, pick Transform and then Reflect along a vertical axis. This flips that cross-section so that it's now a mirror image of the original one. To figure out where to place that mirror image, we'll now make a stance line whose length is the same as the interior diameter of the vessel. To do that, I'll start by making a horizontal line that extends from the center line to just inside the rim. Then I'll go to the Object menu, select Transform, and then change the scale on the horizontal axis to 200%. This gives me a line segment that's equal to the interior diameter instead of the interior radius. It looks like I need to zoom out again, and as the drawing is now going off the edges of my virtual paper, I'll go back to the first layer and add a white rectangle that's a lot larger, making sure that that layer is in the background. After resizing the image again, I now shift that stance line so that it just touches the inside of the rim, taking care that I'm moving it and not resizing it. When I'm finished doing that, the center marker on the line segment should line up with the vertical line on the drawing. Next, I shift the image so that I can see the left end of the line and move that reflected cross-section so that the inside of the rim just touches the stance line. Next, I use the Point Selection tool to delete the points on the interior of the cross-section. This leaves only the exterior profile. I'll now draw a vertical line for that center axis. And with the Point Selection tool, I'll move the right end of the stance line a few millimeters to the left to leave a small gap between it and the rim. This is important to make sure that the stance line doesn't interfere with the shape of the rim. I'll next select the cross-section again, and go to the Properties menu in order to pick the fill for the cross-section. The convention for my project is a black fill. Now, because pottery illustrations are normally published at only 1/4 or 1/5 of their actual size, your illustration convention needs to have line weights that are going to reproduce well when they're reduced. It's particularly important to make sure that your line thicknesses are adequate for the exterior, the stance line, and the vertical axis. Save thinner lines to show details on the interior or exterior surfaces. Sometimes, in another layer, you'd also add a horizontal scale on the drawing, especially if you anticipate showing pottery at different scales on the same plate. But I'll skip that here and go straight to saving the file. We can also export the file in a number of formats, such as JPEG and PNG, depending on whether we want to use the graphic in, say, a website or a video. So that the original pencil drawing doesn't show up on the final drawing, you either delete the bottom layer or turn its visibility off. Here's a view of that final drawing in PNG format.
So that's the essentials of drawing pottery. There are lots of fine details that you need to learn if you're doing this a lot. Really, the best way to learn it is by doing it. And there's more specific topics like how you deal with decoration on pottery and that sort of thing that we don't have time to deal with right now. But I hope that was a little bit helpful, considering that we're not able to do the hands-on lab that I would normally prefer to be doing in order to teach people how to draw pottery.
There are some excellent books on archaeological illustration, and I show you a couple of them here. If you'd like to learn more about archaeological illustration, you could consult Chapter 21 of my book, The Archaeologist Laboratory, published by Springer, as well as some of the references cited there, which include standard books on both lithic illustration and pottery illustration. And if you'd like to be updated as I produce more videos on archaeological lab methods and other archaeological topics, please click on the subscribe button down below. Thank you. Stay safe.